Hi grade 10s, it's Miss Thungaraj here. This is our third video for our summative, and today we're going to be talking about solving systems of equations. So I just want to remind you that solving systems of equations simply means taking two lines, graphing them, and finding out when they touch. So that's what we'll be doing today. The page in your summative that you are looking for is this page. It's a page that has apples and bananas and there's equations underneath. That's the page we're looking at, and we're going to solve systems of equations on that page. So we're going to practice a little bit together. We're first going to use the elimination method. And earlier during our Learn at Home period, I made a whole video series about elimination method and substitution method and solving systems. And we learned that elimination method just means adding or subtracting two equations so that you eliminate or get rid of an x or a y. So that's what we're going to do with this equation or this set of equations right here. We either want to add them or subtract them so that either the x's disappear or the y's disappear. But before we head to the algebra, I just want to graph those two equations in Desmos because I want to figure out what the answer should be. So when I graph those two equations, I have got the red line, I've got the blue line, and I see that those two lines touch at 5, minus 7. So the x should be 5 and the y should be minus 7. So when we're doing our algebra, when we're doing our elimination with these two equations, we want to keep in mind that that's the answer that we want to reach for. Okay, so let's try adding these equations. If I add 3x plus 4x, I get 7x. If I add 2y plus y, that gives me 3y. Adding is not going to get rid of an x or a y. So let's try subtracting them. If I have 3x minus 4x, that's going to give me negative 1x. Again, that's not 0x. And if I do 2y minus 1y, that gives me 1y. I haven't got to the 0x or the 0y that I want to get to. So we're going to have to do a little bit of work before we can eliminate in this question. Equations, and we've talked about how adding or subtracting is not going to work right away to eliminate or remove an x or a y. But what I want you to notice is if I took this y, and right now this is a 1y, but if I multiplied 1 times 2, 1 times 2 would be 2y. And if I did 2y subtract 2y, I would get 0y. I would have no y. I would have eliminated. So it seems like that would be a great idea. Let's multiply this 1 by 2. But because it's an equation, when you have an equation, you need to do the same thing to the rest of the equation. So if I'm multiplying this by 2, I need to multiply this by 2, and I need to multiply this by 2. So let's rewrite what we have. On top, we have 3x plus 2y is equal to 1. On the bottom, 4x times 2 is 8x. 2 times 1 gives you 2y. And 13 times 2 gives you 26. So let's subtract those equations because 2 minus 2 gives me 0. And if it's 0y, I don't need to write it down. So I have eliminated it. So let's try 3x minus 8x would give me minus 5x. 1 minus 26 would give me minus 25. And then what I want to do is I want to get my x all by itself. So I need to divide by minus 5, divide by minus 5, and x, negative 25, divided by negative 5 gives me 5. That means my solution to the system of equations, or the intersection point, if I were to write it, first you write the x and then you write the y, the first number should be 5. Let's go back to Desmos just to check. And when we look at Desmos, we see that x should be equal to 5. Now, the only thing we are missing is that y should be equal to minus 7. So let's do that part with algebra right now. One of the equations, it doesn't matter which one I take. I could take the top one or the bottom one, and I want to use one of those equations. So let's use the top one. So I'm going to use 3x plus 2y is equal to 1. And it wouldn't matter which one of the equations you used, you should still get the minus 7 for y. Now, let's go back to what we know already. We know that the x is equal to 5. We know that the x is equal to 5. So up here in this equation, we're going to cross off the x, and we're going to put a 5 here, because we know that the x is 5. So these two numbers are right next to each other. That means I want to multiply them. 3 times 5 gives me 15, plus 2y is equal to 1. I want to get the y by itself, so that means I want to move this plus 15 to the other side. So I'm going to minus 15. These cancel out then. So 2y is equal to 1, subtract 15. That would give me minus 14. And I'm already seeing that I'm going to get the right answer, because when I divide by 2 now, my y is going to be equal to minus 7. So I'm going to take that y, I'm going to move it over here, and I'm going to put a minus 7 right here. So we know that when we were to graph these two equations, the only time that they touch is when x is equal to 5 and y is equal to minus 7. So again, here's the question that you're responsible for in the summative. And the question in the equation talks about a's and b's. So if you don't want to use a's and b's, you can just switch the a to an x and the b to a y. So you can rewrite the equation as 4x plus 2y is equal to 5 and 1x plus 3y is equal to 4.25. The only thing that you must remember is that the x was the a in the question. So when you answer the question at the end, you don't want to say that x is equal to something. You want to say that a, the apples, is equal to something, and the y, when you find the answer for y, that's really the b. So the b would tell you about, the y would tell you about the bananas. So now we're on to part 2 of today's video. We're going to talk about the substitution method. So again, the substitution method is just a way to find where two equations would intersect on a graph. That's the point of substitution method. But when we're using substitution method, instead of subtracting or adding, what we want to do is we want to make one of the equations either y equals or x equals, and then take that y equals or x equals and substitute it or put it into the other equation. Okay, so before we go to that algebra, let's graph these two equations in Desmos so we can see what the intersection point should be. And when I went to Desmos, I saw that those two lines intersected at 1, 4. That means my x should be 1 and my y should be 4 when we use the substitution method. And remember, substituting means first step is to take one of those equations and change them to either x equals or y equals. Okay, so here are my equations, and I want to find which one I can change to either x equals or y equals. And when I look at these equations, I can see that if I took this minus x to the other side, I would just have y equals on the left side of the equation. So let's do that. So I would have y equals 3, and this minus x on the other side would become plus x. That is step number 1 in substitution, to change one of the equations to either x equals or y equals. It doesn't matter which one, as long as you have either just a y here or just an x and everything else on the other side. Now, step number 2 for substitution is, once you've done that, is to then go back and find the other equation. So not the one you've changed to x equals or y equals. Let's write down the other equation. So I'm writing that down. 3x plus 2y is equal to 11. And what I want to do is I want to substitute or put the y equals part into this other equation. So I want to take this, and here it says that y is the same thing as 3 plus x. So what I want to do is I want to cross off the y here, because I know that y is the same thing as 3 plus x. And the nice thing about that is now when you look at this equation, There's only one variable or one letter. I've got x's here, I've got x's here. I can simplify that and find my answer for x. So let's do that now. So I have 3x. Here I have 2 times 3, so that means I have plus 6. And here I have 2 times x, so I have 2x is equal to 11. Now I need to simplify this side. So I need to put together the things that go together. Well, that 3x and the 2x could go together. So 3x plus 2x gives me 5x. And then I've got the plus 6 is equal to 11. And now I'm going to do algebra. I want to find the answer for x. So I want to move everything else to the other side. So I'm going to take away this 6. This will cancel out. I only have 5x here. 11 minus 6 is 5. Divide by 5. Divide by 5. X is equal to 1. That means the intersection point should start with a 1. Let's check with Desmos to make sure we didn't make a mistake. So here I am in Desmos, and I can see that those two lines, they are touching at 1, 4. So that means x should be equal to 1 when the two lines touch. And now somehow we want to use a little bit more algebra to get that y should be equal to 4. So we'll do that together now. So from Desmos and our algebra, we know that x is equal to 1. What I need to do is I need to take my other equation then to find my y. So it doesn't really matter which one we take. Let's take the easier one. Let's take the y is equal to 3 plus x. I know that whatever y is, it should be equal to 3 plus x. I know that my x is equal to 1. So my x is 1. And when I do 3 plus 1, I get 4. So I got the right answer. Let's try it with one of the other equations, because I want to prove to you it wouldn't have mattered which one of the equations I used. So let's take the first one. Let's take 3x plus 2y is equal to 11. I know that my x is equal to 1. So up here in this equation, I'm going to cross off the x and I'm going to put a 1 here. Okay, that means I need to do 3 times 1, which is 3 plus 2y is equal to 11. I want to get the y by itself, so I need to take this plus 3 and I need to move it. So this would cancel out. My 2y would be equal to 11 minus 3 is 8. I'm going to divide both sides by 2. So my y is equal to 4. It doesn't matter which equation you've used, you should get y is equal to 4. And that means that down here in my point, they intersect at 1, 4. Here is your question from the summative, and what you want to do is you want to use substitution. So you want to make one of them either x equals or y equals. So if I look at the second equation, there's 3x and 2y, so that one's not very nice. We don't want to use that one. How about the first one though? If I were to try to make that just x equals, that would be pretty easy. I could have x equals, I could move the minus 3y to the other side, and then I'd have a nice equation that's x equals that I could substitute into the other equation. So maybe you might want to try that. Here is a screenshot of my YouTube my YouTube channel. You'll notice I have 40 loyal subscribers, which is awesome. I also want you to see that if you go to my channel and click on playlists, you will see that there is a whole playlist full of videos for solving systems of equations, an entire playlist for videos that teach you today's topic for the summative. So if you want to learn a little bit more, feel free to go to my YouTube channel, go to playlists and click on that first playlist, Solving Systems of Equations, and it's really going to help you learn even more than you were able to learn in today's brief little video. Have a great day. Thanks for sticking with math. Thanks for doing lots of work, and I look forward to you watching my next video tomorrow.